this opportunity. Let me tell you, as introduced by Penn already, that WWF is very grateful to be part of this because we regard it as our job to bridge the interface between science and policymaking. So what we are thinking of our job to be mainly is to communicate to policymakers the latest science and the most relevant science. I don't have to probably say in this context here that we are at a crucial time for climate change. This is the most crucial year for all of us, for the Earth and its functioning. We have to come to a solid deal in Copenhagen that limits global warming. So let me take this, what has been said here, one step further and say that in that respect, a most important significance of the Catlin Arctic Survey data lies out with the Arctic. It points to how climate change in the Arctic will affect all of us, and earlier and stronger than predicted. And this is because, as Peter has already mentioned, the Arctic, and especially the Arctic sea ice, hold a crucial and central position in the Earth's climate system. Remove the sea ice, and we are left with a very different, much warmer, and very different world. We have recently summarized these newest signs past the fourth assessment report of the International Intergovernmental Panel on Climate Change in 2007, because important evidence is accumulating that shows how climate change is actually hitting the world earlier than projected, and how our Earth is more sensitive to the warming that we introduce. We have released the Arctic Climate Feedbacks report that shows how the climate change impacts in the area of the world that is most affected by climate change already is and will in the future, if left unabated, affect the Earth. In this report, the sea ice and its condition is holding a central position because it is responsible in parts for what is called Arctic amplification, the fact that the Arctic is actually warming much more than the rest of the globe, in fact, at about twice the rate over the recent decades than the rest of the Earth. But on from that report actually shows what is the current understanding, the current scientific understanding of what it actually means to all of us that the ice is melting. And it points a very sobering picture of what the diminishing ice and the warming temperatures in the Arctic actually mean for our weather, atmospheric circulation, because most of the weather that we experience in the northern hemisphere is really made by the heat difference between the tropics and the Arctic. If you diminish that cold in the Arctic, you change the fundamental patterns of weather in the northern hemisphere, of atmospheric circulation in the northern hemisphere. You will actually impact also on ocean currents, and you will impact on how the Greenland ice sheet and its melting will affect global sea level rise. The latter, what I just mentioned, global sea level rise and the effect of ice sheets on it, have actually been partly excluded from the fourth assessment report of the IPCC because at that point no evidence was strong enough to make a projection possible of the fate of the ice sheets on global sea level rise. We are now getting much closer to that, and just to give you an example, the report finds that while IPCC fourth assessment report has said global sea level rise by 2100 will be around between 30 and 50 centimeters. If you include the increasing melt of West Antarctic and Greenland ice sheets into global sea level rise projections, we will be at the higher end of the most recent projections that point to the real sea level rise in 2100 being much more than 1 meter. And more importantly, that is only the beginning of the contribution of the ice sheets to sea level rise, and it will probably be an irreversible trend should we not hold global warming. Another very important aspect mentioned in 3 chapters in this report also starting off with the sea ice and the diminishing albedo and the Arctic amplification of temperatures that result from it, is the effects coming out of the Arctic of the Arctic carbon cycle. There are about twice the amount of carbon held in Arctic permafrost soils than is currently contained in the atmosphere. There is an immense and very poorly quantified amount of methane hydrates stored in subsea sediments in the Arctic. And in some regions of the Arctic, this methane hydrate is already becoming vulnerable, and increased methane emissions over the ocean surface, in the atmosphere above the ocean, have already been recorded in the last 2 years. So I say this because we, coming back to the very start, think it is on us to communicate, and to communicate with examples that communicate as well as the Catlin Arctic Survey data, what, to policymakers, what has been happening with the Earth since the last assessment report of IPCC has been done. And this is a crucial year to do it. In the end, we have to span the arch from this kind of physical evidence that we have all the way to a global carbon budget that we cannot exceed in this century. What you see here with this diminishing ice thickness and with the potential loss of summer Arctic sea ice in about 10 to 20 years is the result of a warming of about 1 degree globally. We are already committed to 1.4 degrees globally. We have to, under all circumstances, limit this warming to about 2 degrees or less than 2 degrees warming if we can. To do this, the latest science shows that we have only a limited carbon budget, a limited amount of emissions that we can actually put into this atmosphere. And if we want to limit the risk of warming to about 20 to 30% of if we want to limit the risk of exceeding 2 degrees to about 20 to 30%, we only have 1,000 gigatons left to put into this atmosphere. It is not much, and if we continue on the current track, which is actually following IPCC scenario A1FI, intensive dependency on fossil fuels, we will end up with a warming of more than 4 degrees in 2100. That already can be said to be translated into that we have to cut our emissions globally by 80% until the year 2050 and eventually become carbon neutral. It also, given a closer look at annual reduction rates, peak dates, and the time that CO2 that we emit into the atmosphere stays there, necessitates that we actually ask for the industrialized nation, especially the European Union, to reduce emissions by 40% until 2020. And I think I stop it here and hand over back to the moderator.
Thank you very much indeed, Martin.